Hello my lovely students, you're welcome to a new lesson. Today, I shall be teaching you sequences and series 1 and we shall be looking at arithmetic progression, AP. From definition, a sequence is a list of numbers that follow a pattern or a rule. A series is obtained when the terms of a sequence are added together. An arithmetic progression, AP, or linear sequence, is a sequence of terms that increase or decrease consecutively by adding or subtracting a constant known as the common difference. An example of an arithmetic progression is 9, 12, 15, 18, and so on. This is an arithmetic progression which increases by the addition of 3 each time, having a common difference of 3. Another example of an arithmetic progression is 38, 31, 24, 17, 10, and so on. This is an arithmetic progression which decreases each time by the subtraction of 7, having a common difference of -7. Let's learn more about arithmetic progression, AP. Let's learn about the formulas in arithmetic progression, AP. Number 1, the n term of an AP. Number 2, arithmetic mean. Number 3, the sum of an AP series. Number 1 formula. The n term of an arithmetic progression, AP, is U subscript n is equal to A plus n minus 1 in bracket times D. In this formula, A represents the first term, n represents the number of terms, and D represents the common difference. Please take note of this formula. Number 2 formula is the formula for arithmetic mean, B. The arithmetic mean is the middle term of 3 consecutive terms of an arithmetic progression, AP. The formula for arithmetic mean is B is equal to A plus C divided by 2. Here, A, B, C represents 3 consecutive terms of an arithmetic progression, AP. Please take note of this formula. Formula number 3. The sum of an arithmetic progression, AP series, S subscript n. Here we have 2 formulas for the sum of an AP series. The first formula is S subscript n is equal to n over 2 into A plus L in bracket. The second formula is S subscript n is equal to n over 2 into 2A plus n minus 1 in bracket times D. Here, A represents the first term, L represents the last term, n represents the number of terms, and D represents the common difference. Please take note of all these formulas involving arithmetic progression, AP. Let's see our first example for arithmetic progression, AP. Example 1. Find the next 2 terms of the following sequences or set of numbers, AP. The sequence in question A is 5, 8, 11, 14, 17, and so on. While the sequence in question B is 23, 19, 15, 11, 7, and so on. Let's see the solution to example 1a. But before we do that, can you tell the rule or the pattern in the sequence in example 1a? Let's see if you are right. The sequence in example 1a is 5, 8, 11, 14, 17, and so on. The rule for the sequence or set of numbers AP is any term plus 3 or add 3 each time. I hope you got that right. Since the sequence showed the first 5 terms, then the next 2 terms will be the 6th term and the 7th term. Following the rule or the pattern, the 6th term will be 17 plus 3, which will be 20, and the 7th term will be 20 plus 3, which will be 23. So the next 2 terms will be 20 and 23. Following the explanation to the solution of example 1a, can you tell the next 2 terms in example 1b? Let's see if you are right. The sequence in example 1b is 23, 19, 15, 11, 7, and so on. The rule for the sequence or set of numbers AP is any term minus 4 or subtract 4 each time. Since the first 5 terms of the sequence is given, then the next 2 terms will be the 6th term and the 7th term. Following the rule or the pattern for the sequence, the 6th term is 7 minus 4, which is 3, and the 7th term is 3 minus 4, which is minus 1. So the next 2 terms of the sequence are 3 and minus 1. I hope you got that right. Let's see our second example for arithmetic progression AP. Find the 5th and the 8th terms of the sequence whose nth term is question A, 2n plus 1, question B, 3 minus 5n. Let's see the solution to example 2a. The general or the nth term of the sequence in example 2a is 2n plus 1. To find the 5th term, n is equal to 5. Substituting 5 for n into the general or nth term, which is 2n plus 1, becomes 2 times 5 plus 1, which is equal to 10 plus 1, which is equal to 11. So the 5th term is 11. In the same way, to find the 8th term, n is equal to 8. Substituting 8 for n into the general or nth term, 2n plus 1, becomes 2 times 8 plus 1, which is equal to 16 plus 1, which is equal to 17. Hence, the 8th term of the sequence is 17. I hope the solution to example 2a is clear to you. Now, following the explanation to the solution in example 2a, can you tell the 5th and the 8th terms of the sequence in example 2b? Let's see if you are right. In example 2b, the general or nth term of the sequence is 3 minus 5n. To find the 5th term, n is equal to 5. Substituting 5 for n into the general or nth term of the sequence 3 minus 5n, we have 3 minus 5 times 5, which is equal to 3 minus 25, which is equal to minus 22. Hence, the 5th term of the sequence is minus 22. In the same way, to find the 8th term, n is equal to 8. Substituting 8 for n into the general or n term of the sequence 3 minus 5n, we have 3 minus 5 times 8, which is equal to 3 minus 40, which is equal to minus 37. Hence, the 8th term of the sequence is minus 37. I hope you got that right. Let's look at our third example for arithmetic progression AP. Example 3. Given the arithmetic progression 9, 12, 15, 18, and so on, find its question A, 8th term, question B, 99th term, and question C, the nth term. Let's see the solution to example 3A. In the arithmetic progression 9, 12, 15, 18, and so on, the first term A is 9. The common difference D is the second term minus the first term, which is 12 minus 9, which is equal to 3. The common difference can also be obtained by calculating the third term minus the second term, which is 15 minus 12, which will give you 3. Or by calculating the fourth term minus the third term, which is 18 minus 15, which is also 3. Next, can you still remember the formula for the nth term of an arithmetic progression AP? Let's see if you can. The formula for the nth term of an arithmetic progression AP is U subscript n is equal to A plus n minus 1 in bracket times D. I hope you got that right. To find the 8th term, n is equal to 8. Substituting 8 for n into the formula for the nth term of the arithmetic progression AP gives U subscript 8 is equal to 9 plus 8 minus 1 times 3. This will give us 9 plus 7 times 3, which will give us 9 plus 21. The 8th term of the arithmetic progression is 30. In other words, when you keep on adding the common difference 3 to the arithmetic progression 9, 12, 15, 18, and so on adding 3, the 8th term in the sequence will be 30. I hope the solution to example 3A is clear to you. Next, let's see the solution to example 3B. To find the 99th term, n is equal to 99. If you substitute 99 for n into the formula for the nth term of the arithmetic progression, what will be the 99th term in example 3B? Let's see if you are right. For the solution to example 3B, the arithmetic progression is 9, 12, 15, 18, and so on. The first term A is 9. The common difference D is 3. The formula for the nth term of an arithmetic progression is U subscript n is equal to A plus n minus 1 in bracket times D. To obtain the 99th term, n is equal to 99. Substituting 99 for n into the formula for the nth term of the arithmetic progression, the 99th term is U subscript 99 is equal to 9 plus 99 minus 1 in bracket times 3. That will give us 9 plus 98 times 3. That will give us 9 plus 294. The 99th term of the arithmetic progression is 303. I hope you got that right. Next, let's see the solution to example 3c to find the nth term. To find the nth term, n is equal to n. Substituting n for n into the formula for the nth term of the arithmetic progression, use subscript n is equal to a plus n minus 1 in bracket times d, gives us use subscript n is equal to 9 plus n minus 1 in bracket times 3, which will give us 9 plus 3n minus 3. Collecting the like terms, the nth term use subscript n is 9 minus 3 plus 3n. The nth term of the arithmetic progression is 6 plus 3n. I hope all the solutions in example 3 are clear to you. Let's see our fourth example for arithmetic progression AP. Example 4. Roman figure 1. Find the arithmetic mean of the following numbers. Roman figure 2. Write the arithmetic progression. Question A. The numbers are 20 and 26. And question B. The numbers are minus 6 and 2. Let's see the solution to example 4a. But before we do that, can you still remember the formula for arithmetic mean? Let's see if you can. The formula for arithmetic mean is b is equal to a plus c divided by 2. I hope you got that right. In example 4a, the numbers are 20 and 26. So a being the first number is 20 and c being the third number is 26. So the arithmetic mean b is 20 plus 26 divided by 2. That will give us 46 divided by 2. The arithmetic mean in Roman figure 1 is 23. In Roman figure 2, the arithmetic progression is A, B, C. Since A is the first number 20, B is the arithmetic mean 23 and C is the third number 26, the arithmetic progression is 20, 23, 26. Of course, this is an arithmetic progression because it has the common difference 3. I hope the solution to example 4a is clear to you. Next, can you find the arithmetic mean in example 4b, talking about the numbers minus 6 and 2? Let's see if you can. In example 4b, the first number a is minus 6 and the third number c is 2. The formula for arithmetic mean is b is equal to a plus c divided by 2. Hence, the arithmetic mean b is equal to minus 6 plus 2 divided by 2. That will give us minus 4 divided by 2. The arithmetic mean in Roman figure 1 is minus 2. I hope you got that right. Now that we know the arithmetic mean, can you write the arithmetic progression in Roman figure 2 in example 4b? Let's see if you can. In example 4b Roman figure 2, the arithmetic progression is A, B, C. Since A is the first number minus 6, B is the arithmetic mean minus 2, and C is the third number 2. The arithmetic progression is minus 6, minus 2, and 2. I hope you got that right again. Of course, this is an arithmetic progression because it has the common difference 4. I hope the solutions to example 4 they are all clear to you. Let's see our final example of arithmetic progression AP. Example 5. Find the sum of the first 24 even numbers. Let's see the solution to example 5. The sum of the first 24 even numbers S subscript n is 2 plus 4 plus 6 plus 8 plus and so on until we get to the last number or 24th even number, which is 48. Here the first term A is 2. The number of terms n is 24. The common difference D is the second number minus the first number, which is 4 minus 2. The common difference is 2. The last term L is 48. To get the sum of the first 24 even numbers, which is an arithmetic progression series, let's use the first arithmetic progression series formula, which is S subscript n is equal to n over 2 into a plus l in brackets. When you substitute 24 for n, 2 for a, and 48 for l into this formula, what will be the sum of the first 24 even numbers? Let's see if you are right. We have S subscript 24 is equal to 24 over 2 times 2 plus 48 in brackets. That will give us S subscript 24 is equal to 12 times 50. The sum of the first 24 even numbers becomes 600. I hope you got that right. Please note that apart from using this first formula for the sum of an arithmetic progression series to solve example 5, we can also use the second formula for the sum of an arithmetic progression series to solve example 5. Now, can you still remember the second formula for the sum of an arithmetic progression series? Let's see if you can. The second formula for the sum of an arithmetic progression series is S subscript n is equal to n over 2 into 2a plus n minus 1 in brackets times d. I hope you got that right. Now we can also use this second formula to find the sum of the first 24 even numbers in example 5. Substituting 24 for n, 2 for a, and 2 for d into this second formula for the sum of an arithmetic progression series, what will you obtain as the sum of the first 24 even numbers? Let's see if you are right. Substituting 24 for n, 2 for a, and 2 for d into the second formula for arithmetic progression series, which is S subscript n is equal to n over 2 into 2a plus n minus 1 in bracket times d, we are going to have S subscript 24 is equal to 24 over 2 times 2 times 2 plus 24 minus 1 in bracket times 2. This will give us S subscript 24 is equal to 12 times 4 plus 23 times 2. This will give us S subscript 24 is equal to 12 times 4 plus 46, which will give us 12 times 50. Once again, the sum of the first 24 even numbers is 600. I hope you got that right again. Please take note of all the solutions for the examples for sequences and series 1 involving arithmetic progression AP. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic sequences and series 1 involving arithmetic progression AP, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.